This is the first of the two backend handover sessions. My name is Ola Nilsson, and me and Lukas Torchan will be doing this. Today, let's see. Oh, I was clicking the wrong thing here. Right. Today, I will just give a really brief background and intro, and then I will let Lukas present the architecture and how we deploy and the data models that we use. And tomorrow I will talk about the API design and how you as a developer would change things and some of the ideas and how we've done things. That is the idea. It will be quite, we try to make it informal, so you can come with questions, and we'll also try to make it hands-on. So I think if you haven't for today, at least for tomorrow, check out the code so that you can, maybe have done this already, but check out the code and make sure that you have the access that you like. Right, okay, so you all know this, you've seen it before, but I think it's important to just remember that Flowify is a tool for what we call low-code users. It's if you're an expert in programming and really good at it, you're not the direct audience. You may have your own tools. You may want to write things in Python yourself, and you know how to connect all the data sources. But typically at Equinor, we have a lot of people who who are not so proficient in these areas, but still have a lot of expertise in their domain. And Flowify is a tool to help them produce and share and manage their workflows. And the workflow in this setting is a kind of recipe that you bake to produce something. And the typical workflow is you access or download cloud data, you modify it somehow, or you derive it or construct new data, and you store it to a new location. That is a typical pattern. The history for the Flowify project, and this is I've been in the project from part 2 to 3, so I was not in the initial pilot. So this is by hearsay. So Juho Smisat spearheaded the project and had a really nice idea of how we can do this. So they started out with making a pilot, and I think they kind of showed that this is a good thing to do, but then they also realized the need for robust orchestration. That is when you execute these workflows, implementing this in-house, it's not really a viable option. It's very expensive and difficult. So we started looking at alternatives, and they found Argo workflows. That's the word. And Fahad, me, and Sylvian came into the project, and we made a step 2 MVP that kind of showed how we could do the same, but using Argo, and don't have to implement everything from scratch. In this phase, we realized that Argo is a really nice project. We can use it, but it's very complex, and basically you kind of expose the full Kubernetes interface, and that is not the right abstraction level for the intended audience. So we decided to take a step back and create Flowify as it is today as a language or a model of how we what we think of the definition of a workflow as it is, as we've made it, and created this collaborative workflow manager with databases for workflows and jobs and so on. And then we use Argo and the Kubernetes system, which is really good at what it does in the background, but that is not visible to the user, to the end user at least. Through this, there was many contributors, and please correct me if I missed any, Matt and others, but here are the names of the people I've worked with in the project. And just a quick note, so Lucas, I, and Sylvian, who is no longer with us, come from this external company called Blueware. So that you know, I no longer have an internal Equinor account since I've switched to another project. But Lucas has both Blueware and Equinor access. So that was about the introduction, as much introduction as I was going to give you. And I would like to hand over to Lucas, and then I will see you, I hope, tomorrow for some Go API discussions. Okay. And don't hesitate to mail or me or whatever, and I will answer. Okay, Lucas.
Yeah, so then I will share my screen. Allow me to set up this one. Okay, can you see my screen?
Yeah.
Yes. Yeah. Okay. So then the system is complicated, and we don't have a lot of time. So to be honest, I think that we will only touch tip of iceberg today. But I think that this should be enough to run everything on your local machine, and then we'll be able to add something, to change something, and so on. So at the beginning, we'll start with, and I will jump from presentation to code and to command line to show how it works. Yeah, and so we will start with the architecture and the deployment, so the local setup. Next, we will go to run tests locally, then run system with Docker, both test and dev environment. Next, I will show some tricks with the MongoDB, with the access to this MongoDB and access to Kubernetes from local host with kubectl and access to Argo and so on. Next will be data model. So I will explain thanks because Ula once came up with this comparison to recipe, and this comparison is just brilliant. So I will explain the components, workflow, and jobs, and at the end I will say a few words about the transpilation. Transpilation is the process of translation, the document from the Flowify language to Argo workflow. So basically, to be honest, in the repository, the README file is quite sufficient to run most of the stuff, but it's good to understand what is going on. So our architecture, local architecture, looks in this way. We have a Mongo server, which is the MongoDB, and this is a container. We have a Flowify server, so this is our server, the backend server, and we need a Kubernetes cluster with installed Argo to be able to run all the stuff. So we created a Docker Compose file, and this Docker Compose file allows to run all of those stuff with one command. And when we are creating this kind cluster, it's from the developer point of view is quite time consuming. So this kind cluster is producing a side effect, which is a cluster control plane, and this cluster control plane is something what takes the most of the time to set up. So there is a trick if you would like to rebuild server, how to do not get down the whole Docker compose just to keep this cluster control plane alive. And then we're exposing some ports from this Docker setup. We are exposing port 27017, which is for Mongo server. We have a port for Flowify server. This is the API. Yeah, and then of course you can run the Flowify user interface also as the Docker, what is described in the README file. However, I won't focus on this today. This is out of scope for today. Yeah, so we can start with the Docker Compose file, because to be honest, to run the yeah, to be able to run the dev environment, the only thing which we need is this Docker Compose, and everything is described in the README file. So if we will go to dev folder, then we can just run the Docker Compose, deattach it, so then we don't get the logs from the Docker files. So if I will go to my command line, I'm already in the Flowify workflow server. I have a Docker. So this is a Docker version 20.10, and I have also Docker Compose. Yeah, so start a version, and to be honest, this is enough to if you have all of those stuff on your local machine, then you can go to dev server, and here we have this Docker compose yam file. And the Docker Compose YAM file here is the most important part, because it's building the services. One service is the Mongo server, and the container name after creating is the Mongo server, and it's exposing ports. And we add some health check, and this health check is quite important because next service cluster, and the cluster is the kind cluster. And why we are using the kind cluster? Because kind cluster, this is a Kubernetes cluster which allows to run Docker inside Docker. So here we have mounting volumes where we are mounting the local Docker socket to class to inside the cluster. So from inside the Docker container, when it is running, we are able to run some additional stuff on our localhost Docker instance, and this part is very important. But this one cluster service is depending on Mongo service. So the Mongo service need to be up and running to be able to start the cluster, and this is the reason why we have a test health check test. And one more important thing here is that MongoDB need to be set up as the replica set. Replica set, maybe what is replica set is out of the scope, but this is some kind of setup of Mongo where you have a few replicas of database, and this is required because we are doing some transaction in MongoDB, and those transaction requires replica set. This is how Mongo is built. and this need to be taken into account. And the transactions are important because if we would like to make an operation atomic, then in MongoDB, operation is atomic only on the operation on single document. So if you would like to make atomic operation on reading and writing to multiple documents, then we need to use transactions. Yeah, and example of such a transaction is the when we are patching some component. I think that Ula will tell tomorrow a bit more about this, but patching component required to check if we are working on the latest version, because we have a versioning of the document in our system, and then if we are trying to patch the latest version, then the operation is permitted. We can do it. And if we are trying to patch not the latest version, then this operation is not permitted. So it cannot be done. And transaction is preventing, for example, the race where it can happen that two users will try to patch the same document. So if you will patch the document, then if you would like to update the document, then you can update only the newest one, document. Okay, so this is our service for Mongo. This is our service for cluster, and we will go back to this cluster because running the cluster is using some also some tricks. But then we also have a server, and this is a Flowify server. So this is a Flowify server is a service which provide our backend. And we have a network. So the name of this network kind, this is important, it cannot be changed because kind cluster, when it's running Docker inside Docker, it requires that the name of the network is kind. Then the services can communicate all the nodes and in Kubernetes and so on. So yeah, this command is quite easy. We can do Docker compose up the attach and we will build our server. So if I will run Docker compose run server, because server is depending on cluster, and cluster is depending on Mongo, everything will run. So yeah, I will stop it for a second. There is one more trick which you can use. You can use a compose Docker CLI build equal to 1, this variable. Then whenever you will rebuild the server next time, it will rebuild only this service which is not in the newest state. So this can speed up the operation during next time. Yeah, and the first one run, it will take some time because it need to download all the images and it need to build all the stuff. So in the meantime, I can go back here to cluster. This service cluster is using the dockerfile.cluster. So we have this dockerfile.cluster file here, and this file is defining the Docker image where we have some pre-built stuff, and then what we are doing, we are copying the cluster runner script sh and some additional stuff. So this cluster runner script, it's cluster runner is here. So this cluster runner script is I will go back to this keep kind cluster alive later, but this cluster runner is executing a Docker command, which is running this cluster control plane, and cluster control plane runs the Kubernetes cluster. But when the Kubernetes cluster is up, then we need to do one more thing. We need to install Argo stuff. So here is a command kubectl apply, and this is a customization. So we have this Argo cluster install, and so if tomorrow there will be a session about the infrastructure, maybe the infrastructure will be explained better, but we created a simple Argo installation template. So here we have a customization file, which is using two resources, base and the sandbox project A. So inside the base, we have a bunch of stuff to install, and we are starting with the namespace. So first we are setting up the namespace for our Argo cluster. Next, inside the customization, we have configs mapped. So we are setting up some config maps. And yeah, so those configs maps are used later for some authorization and for some for setting the artifact repository, which is using the Mimio. Mimio is a service is a Kubernetes service which allows to add some storage for the nodes which are running inside Kubernetes. And later we are adding some secrets. Secrets are important. So, but here we are just passing the secrets for the Mimio to access the Mimio, and the access key is admin and the secret key is password. Next, we are using some external YAML file to run the Argo server, and this installation is using all of those stuff which has been set up earlier. And then we are adding some cluster roles, and we are adding some deployment, and we are running some service. So this is installation of Argo, and then we have also in our main customization file, we have also a sandbox project A. So inside the sandbox project A, we also have a customization file which is setting up some namespace. So for sandbox project A, the namespace is sandbox project A. Then we have some configuration maps, some roles, and some secrets. So secrets are just the same for Mimio, because this namespace also need to have requires access to Mimio. And we have some roles, and those roles define in some way the authorization for our users. So this file is important. Yeah, but basically when everything is going well, so we have a create Mongo server, which is done. Then we have a create kind cluster server and create Flowify server. So if we will go to Docker ps all, you can see that we have a Flowify server, which is exposing port 8842. We have a cluster control plane, and we have a kind cluster, and we have a Mongo server. So now there is a trick how we can access the. Okay, let's start maybe with the first service from our Docker Compose is Mongo server. So if you would like to get the IP of the Mongo server, then Docker inspect. Docker inspect allow to do this, and if you will do Docker inspect, then you will get the IP address this service. So it's 172.24.02. And then if you have Mongo shell, for example, you can connect to this host. So it's 172.24.02, and the port was 27017. So then you will get the database connection. So this is a connection string. You can use the connection string instead. And if you will, so we are right now connected to replica set 0, because in our Docker compose file, we have some command which is setting the replica set only one replica set. So we have only one replica set 0 to minimize the using of the resources of the local machine. And if we will do some show databases, we will see that we have only the admin config and the local. So those are the databases from MongoDB. Yeah, and so this is how you can connect to Mongo database. Next, in our service in Docker Compose, we have a kind cluster, and so the trick is explained, I think, so in the README file. So here is the way how you can get the IP of cluster control plane, and then we have okay. So if we will do then if we will do Docker inspect, and we will do some filtering to get only the IP address of the cluster control plane, then we can save this IP to such variable. So if I will execute this one command, we will get the IP address in the kind network of cluster control plane. And to be able to use the kubectl to get deployments, for example, or to just it wasn't a good idea. Kubectl get pods. Then if I will try to get pods from CTL, I'm not able to do it because I don't have a kubeconfig set up on my local machine. So to be able to set up a kubeconfig, you can use this second one command from here. So it's docker exec cluster control plane. Okay, so let's copy this one. So what this method is doing, this method is just logging to cluster control plane and is printing the admin conf file. So in this admin conf file, we have the description of the cluster. We have the server of the cluster together with the port, and then we have certificates and key to connect. So all of this need to be added to our kubeconfig file to be able to access the Kubernetes from our local machine. But here we have a cluster control plane, and sometimes in Docker the DNS won't allow to use this name. So there is a trick here where inside the output from this command, we are using the substitution of cluster control plane with our environment variable Kubernetes service host. And at the end, this file is copied to our .kube config file. So if I will do this right now, then I can, so everything is set up. I can go back to kubectl, get pods, and we will see what we have. No resources found in default namespace, so we can check all namespaces. And then we will see that we have a Argo server. In the namespace Argo, we have Minio service, and we have a workflow controller. So those are the services which are set up when we are installing the Argo. Yeah, and basically this is something what is very useful. Okay, so I have something here. Was there any question? If you have any question, then don't hesitate to interrupt. Why kind instead of Minikube K3 or something? So kind is the only local cluster which I found that is able to be run as Docker in Docker. So because what we are doing, we are running a Docker file, and from inside this Docker file, we are running a cluster control plane on our Docker local host instance. So this is the reason. And kind is also used by Kubernetes to run the tests. So when Kubernetes is running the test, they are also using Docker in Docker, and they are using the kind cluster. And this is very good question, and is quite important, because we also have a test which we are running when we are, for example, making a pull request in GitHub. So all those tests are run inside Docker, and using this approach, we are able to do the test in GitHub also. So yes, so this was a very good question. Yeah, so then we know how to run our services, and you can use a Postman right now, or you can run a front end of our Flowify to access. So for me, the easiest way to access the backend server is to create a Postman using the Jupyter notebook. So it should be soon here. So I'm just using the request in Python to make some connection to our API server. So when we will do all the imports, here I have some setups, and okay, so there are some ways how to run the service without the authorization, but it's easier to just create the token which will authorize us as the user, and then we also can inform what kind of roles do we have. So in this example, we have a role sandbox developer admin, and the sandbox. So this is a JVT encoded token. So if I will execute this cell, we can and here I'm creating the headers for our request. So if we will take a look at the header, we can see that we have an authorization header where we have a barrel token, and this token is just this encoded token. So you can of course copy this one into your browser or Postman, and just to inject this token if you would like to do the request in other way. Yeah, but this just a basic setup. So then I defined some method: the get method, post method, update, save, and delete. So all of those methods were used by me when we were working on this project, just to validate if everything works okay and so on. So if we will execute, for example, the get method on the API v1 user info endpoint, then we will get the information that the user is this one defined here. So is name is flow. Then we have the email, OID, and the roles. The roles are most important here, and we can also list workspaces. So we have some items here, and the first item is the sandbox project A, and what kind of roles our user have inside this workspace is user and the admin. And for sandbox project B, we have only the role of user. So this is defined when the user has a role here defined, it will check the everything inside the Argo to in Argo config to check the authorization of the user. Yeah, but this is just some information. Okay, so we know how to run the Docker compose file. As I mentioned, we have this keep kind cluster alive, because if I will go to my command line and I will do something like Docker compose down, then everything will be stopped, and it will take some time to stop all the stuff. And we can go to our code. We can check keep kind cluster alive. This environment is set to false, so it won't keep cluster alive. So now if I will do Docker PSA, all the services were removed. And what we can do for development, we can set this up to true. We can save this one, and we can do Docker compose up the server, and it recreating the cluster control plane right now, and it takes some time to recreate this cluster control plane. I'm showing this because when we will kill all the service right now with this environment variable, change it to true, there will be some error, and this error is because when we are keeping some service from Docker Compose, then the network cannot be removed, and this is something what you need to keep in mind, that it is in this way. Yeah, let's wait for creating. Yeah, and as you can see, creating this cluster control plane took a really long time. So it's good to do not kill this one when you're making your development work. If we will do Docker PSA, so we have all the stuff right now. And if I will do Docker compose, down, right now we can kill the kind cluster, we can kill the Flowify server and the Mongo server. But we should to get the error about the network. It works a bit slow because I'm sharing on Teams, and this requires a lot of resources. Yeah, but we get this error that the network cannot be removed. But right now, if I will do Docker compose up, it should be faster. Because the cluster control plane exists. Yeah, and as you can see, it was faster. So okay, we have this part. So going back to agenda, we have the local setup architecture described. Then we have how to run the system with Docker, and this was the dev environment. So we also have what is described in README file. So you can also run test, and we have two types of test. One test is the unit test, and the second one is end-to-end test. So this everything is described in the code. However, we also make some make file to allow to run all of this stuff. So if we will go a level up, and then we will do make and we can do Docker unit test. So everything will be set up. So this is the app is building right now. Everything is downloaded. So yeah, one more time, using the build kit, Docker Compose build kit would be good idea to speed this up. But basically, all the tests will be run, and we have a lot of tests in our structure of the repository. We have such things like API server. So the API server will be described tomorrow by Ula, but we have some tests here which are running. Then inside the out method, we also have some tests for authorization and for Azure token. Inside models, where we are defining all of our data models, we also have some tests which are checking something like dereferencing the data structure and so on. So all of those tests, also for transpiler, we have some tests. All of those tests are running as the unit test. And as you can see, Flowify workflow server app exit with codes 1, and so we didn't get any error message here. So all the tests pass, and the test also create a coverage for us. So if we will do ls test outputs, we can see that we have a test from unit log. So if we will do cut test outputs unit tests, so we will get the information that this running test list volumes pass okay. So all the tests inside this one test has passed, and then we have a coverage of our test and codes. So all the information are here. So this is a way how you can run the unit test. And also we have in our make file, if we will go here, if we will open a make file, we have a Docker unit test. We have a Docker end-to-end build, test, and test run. So we can do make Docker and end-to-end test run. So it will run the end-to-end test. It also will take some time. This is made okay. So all the tests which are in Docker are useful because of the deployment. So whenever you are doing a pull request, you will get the output from the test, all type of test, and you won't be able to do to merge if the test won't pass. And this is also useful for local development. So when you will change anything in your code and you would like to run the test, then you can just use Docker. But sometimes Docker requires some time to to execute the test. So we can wait for the end of the test. There is an easier way. If you have Go install it in your environment, then you can do also make unit test, and then all the tests will be run. Everything here goes smooth and fast because all of those tests which we have are cached, because I didn't change anything in my code, so the tests were run some time ago. So all the tests are going good. So we can remove this one folder. Yeah. So we have a local setup architecture, how to run tests locally using the makefile. And inside this makefile, if you would like to know how the tests are running, everything is described. So when we are running the unit test, then we are doing go test, and we are listing some folders where the test should be looked for. And inside the unit test, we are excluding the end-to-end test from making the test. So this is described inside the makefile. So a lot of useful command you can and how to build the server, because the build server is the Flowify server is built using this command. And when the server is built, we can take a look at so I need to build the server. So make server. Yeah. So it is building, and then I should to have the build folder, and inside this build folder I have my binary Flowify workflow server, which can be run. Yeah, so all of those stuff can be used to run everything locally, not inside the Docker. Yes, so we have the makefile, we have the test. We know how to run the test locally, how to run the system with Docker, how to run tests, how to run dev environment. We explained what is going on with MongoDB, how to access the Kubernetes from localhost with kubectl. Of course, and when you have your Kubernetes cluster control plane IP, and when you will set up a kubeconfig file. So if you will do docker exec cluster control plane cat and to everything to kubeconfig file, then you can also, if you have Argo installed on your local machine, you can do Argo list, and we will get the information that no workflows were found because we haven't run anything on the Argo yet, so there is no workflows at all. Yeah. Next, let's go to data model, and I just will check my notes if I mentioned everything. So we have a Mongo server cluster. Yeah, this one can speed up the build process, how to access, and explanation about the replica set. Okay, so now we should to go to data model. Whenever you will run your server, so if we will check here, Docker PSA, so we have the Flowify server up and running. Then you can go to some magic address, which is your Flowify server IP, then API port, and API v1 spec to this site. So if we will go here to this is IP of my machine, then the port, and then API v1 spec. So if we will go here, then you will get the spec of all data models. Yeah, and going back to data model, this is in some way quite hard to explain everything how it works, but I was thinking that maybe the best one would be to go through some example. So I created a quite complicated example which allows to understand what is going on. Yeah, but as Ula already mentioned, we have such a type of documents which we are storing in our database. We have a components, we have a workflows, and we have a jobs. So the components are the ingredients of our recipe. The workflow itself is our recipe, and the job is the process of baking. So we are starting with creating a components, and components is something what can be shared between the user, what can be put into the marketplace, and then other user can use those components in their workflow and so on. But basically, our system is creating a DAG. So DAG is a directed acyclic graph. So such a graph can look in this way. We have some, okay, so the most outer circle is the job. Then we have a workflow, and then we can connect some components inside those, inside this, this workflow. And this one component is a graph component, the green one. I hope so that you can see this well, because those lines are not too big, but yeah. So we have a graph, and inside the graph we can have sub components. So when we are building our graph, we can use a already created graph to connect to next one graph to get the outputs. And we have few types of it should be somewhere here. Is it not? I lose. Yeah, so the component can be can have different types. So the component can be a graph. Graph is something what is putting many components into one component. So this is some kind of nested components where the data is flowing from one component to another one. Then we have a component type which is conditional one, and this conditional is some special type of component which allows to create the if-else statement, and such a component have some special structure because it requires a true node, the false node, and the expression. So when we are hitting this component, we are checking the expression. If the expression evaluates to true, then the true node is executed, and when the component, when the expression evaluates to false, then the false node is executed. And the spec of this, for example, this conditional component can be found inside the spec. So if we will go to conditional, then we will see that we have a type property, and the type property need to be a conditional. This is the type of this component. Then we have a node true, node false, and the expression. I will go later to inputs mapping and the output mapping. So the node true and node false can be different type. It can be cref structure. It can be cref version structure, or it can be a component itself. So we are trying to avoid replicate the data a lot in database. So when inside your database you have any component, then you can use the UID of this component, or if the component have a many version, then you can use the versioned version of reference to point out that this one node is using the this component from database. So if we will go back to our postman, we can list a component. Then there is no component at all in our database. But we have also a method to add component, and some very simple example of such a component is a name of this component, the description, the inputs, outputs, and those are the arrays, and right now are empty. And we know that the type is component, and the implementation have a special type any. So if we will add this to our database using the the post method to components, then it will be in our database. So now if I will do list components, we will get the component. We have just one component, so is exactly this one component. And as you can see, we don't have a version information here, or we don't have the UID information here, because all of those stuff are added when we are using our endpoint. So the UID was assigned to this component, and the version was assigned because no such component was previously in database. So the version, the most one is number 1. We have a reserved tag because you can also add the tag to your component, and the reserved tag latest is always assigned and updated by the system to the last version of the component. And we have a pointer to previous version of the component. So if you will create a second version of this component, then it should be pointed out to previous version. Or if you will build a component basing on existing component, but if you will save this component as the new one, then the previous will point to this parent component. Yeah. But going back to our data model, so we have this here. So we have this conditional. So each one component can be treated we have this polymorphism. It can be treated as the reference to component, the referenced version of the component, and the component. So if you would like to know how the CREF schema looks like, is this this is just a format UID. So the example is like this. This object can looks like this. And the version of the CREF have all of those information: the current, the tags, the previous, and so on. So this is how we are using the polymorphism inside our system. Yeah. Also, I already mentioned that we have any component. This is a special type of component which is very useful for the front end, because this component is just a placeholder. If you would like to create a graph, then you can put as the part of the graph some templates of the components which are inside this graph, and this can be done using this any schema JSON. So of course, all of those data models are defined in our code. So if we will go to models.go file, then we can, for example, find a structure validate document. Then we can find the structure. C reverse. No, let's find something what we discussed already. A component. So we already know that the component can be conditional one. It can be a map one, and it can be a brick. Brick is some kind of executing component, and I will describe it later. But the component have a component-based data. So component-based data is defined here. So we have some metadata, inputs, outputs, and we have a type. And then the component is also built with the implementation. So we have a metadata, the component base, and the implementation of this component. Any it contains only the implementation base. But if we will go, for example, to not graph. So it have the implementation base. It have some nodes. It have some edges. It have input mapping and the output mapping. And now I would like to go to show this data model basing on some example. So as I mentioned, I created some complicated graph. What is this graph doing? So we have some node here. This is execution node. So this is a brick, which is taking some inputs parameters, and the name of this input parameter is N1. Then it takes some secrets because we can have secrets environment variables which are used, for example, to access I don't know blob storage container. So you can pass to each one node the value from this workflow secret, and we have a secret v2 inside this brick. So brick is executing component. If I will go to code, and we will take a look at okay, so a brick is defined in this way. We have a type of a brick. Can I make it a bit better? Okay, so we have a type of the brick. Then we have a container. This is required if we will go to our spec and we will take a look at the brick schema. So what is required is a type, and container is required. So the container is something similar like in Argo. So it have some name, it have some basic image, and it have some command which is executed. So of course you can use your own container repository to create your own image, which contains some I don't know Python files or some JavaScript file and so on. And you can then put the name of the image here, so it will be downloaded from your registry, and then the command will be executed. In this case, the command is very simple. It is just doing echo, and here we have some value, and the next one command which is executed is echo secret b1 and secret b2. So as I mentioned it, for this one brick, we have secret b1 and secret b2 passed, and those secrets are always passed as the environment variables. But this one is a parameter. This one is a parameter which in our example have a value 10. So if you would like, okay, then this is a implementation of component 1. this is our first one. Our first one component. So we have the UID of this component. We have some description. We have input, and then we have a type. This is a component, and the implementation. And the implementation is this implementation from brick one. So inside this component, we have some inputs, and the name. This is array. So the first one is the input is the name is seed n1, and then we have a type parameter. So this one is passed as the parameter to this one component, and then we have two inputs which are env secrets. So those two values are used in different way in the brick. So when you are passing an environment secret, then you can always access this one inside your container as the secret, as the environment variable. But if you would like to use the parameter which is passed, then you need to add the arguments. So in this case, the arguments for this command, because this one will take the first one argument which is passed to the command, and the arguments are defined here. So we have the source, we have the port seed n1. So if inside our components we have inputs with the name seed n1, it can be defined as the n1, and we also need to know that we are using the parameters, because we have in our data model. Is there any new question? Oh no. Okay, so if we have the parameter which can be passed as the data from one component to second one component, and this can be a string, this can be a integer value, this can be a float value, or whatever. So this is just, to be honest, everything is passed as the string in this case, like in Linux. And so this one, the value from this one port will be executed here. So we will just print the value which is passed here. So in this way, we are building the component. We have the UID is added by the system, and then we have the description, and we have our inputs. We have type and the implementation. And in this case, implementation is a brick. So this is a basic type of component which allows to make some to execute some operation. Okay, so going back to this example. So in this way, we created this one component. We have those secret B1, secret B2, secret and seed and one parameter value. And then here we also have a bigger one component. This one component contains inside itself two nodes. One node is this one component, and the second one node is this one component. So if I will go to component 2, then I will explain how it works. So we also have some inputs, and in this case we also have some outputs, because we have such inputs. One input is the seed mine. This is a parameter which we will take from here. Then we have a free type of secrets value. Secret. This is a secret G1, secret G2, and secret G3. So the names here can be different than the names here. So we have a way how to map the stuff. So the same secret L1 can be used here, and the same secret L1 can be used here. So we have our inputs for this component number 2, and this is a seed mine. Okay, so this media type integer. This is something what is not implemented at the yet. So the idea was to have a strongly typed function. So when you are passing some parameter, you should to say that you are passing the integer, or you are passing a string, or you are passing a Boolean value, or so on. So to be honest, the media type is added to our data structure, but is not used yet. And then we have a type. This is a parameter, and we also have the secret G1, and the type is env secret, and secret, and env secret. So we have such inputs. But if we will take a look here, we have also some outputs, and we have two output. One is output is the value, and the second one is the artifact value. So the artifact is some way of passing the files, not only the parameter, but also the files. So if we will take a look at our outputs, we have a name value. So the output is value, as you can see here, value, and the type is parameter. But we have also the name artifact value, and the type is artifact. So to be honest, the artifacts are saved in this Mimio service. So when you are passing artifact from one component to other component in Argo, then you are passing only the path to this file. So this is how it is solved. So we have our inputs, we have our outputs, and here we have different type of output. And then we know that the type of this one is a component, and we have a implementation. And for the component one, we had the implementation as the brick. And right now for component two, we have the implementation, which is a graph. So the graph have nodes. So let's focus on the nodes right now. So for the nodes, you need to assign the ID, and then the node can be reference to any node, versional reference to any node, or it can be value as you want. So if we will have everything in our database, and then we will go to component 2 node 1, then we can take this UID, and we can inside our component we can put here the UID, and then there is a system of resolving or of dereferencing the document, and when we would like to transpile to translate this to Argo, everything will be took from the database, and the document will be created without the references. It will put here all the true values in the fly. So this is in some way useful. So we have two nodes in this one graph component. We have one node and the second one node, and right now we have some inputs. For example, seed mine one, seed mine. This is the input for this one component, and we have node 2, which has input value, and we would like to map in some way this one name to this one. So when you are implementing the graph, you have the input mappings. So we can map. Let's start with this one. So we know that the source came from the port here. So if we have the input seed mine, so we can put here the port seed mine to know that we are taking data from here. And then we have a target, and then target in our case, the target in our case is this one node and 3, because this one is only passed to this one component, is not passing to this one component. So we have such a mappings from seed N1. We are passing data to node N3 and the port value. We have also some other mappings. So we are mapping the secret G1 to node. This is this one node, G1 to secret W1 in this way. Okay, so the secrets are passed only to this one node, but this node, this inner node, has also some output values. So if we will go to component to node 1, then we have some inputs. We are those secret W1, secret W2, and secret W3. Then we have some outputs, and we have the output here value, and this is a parameter. And let's assume that this one node is producing some file. So it can download this file from internet. It can, I don't know, download this file from some blob container or whatever, but it will have this file here. So so this type of this output is the artifact. So this one, the green one, is the file which is produced by this node. So when we are okay, and this one component have some implementation, and in this case the implementation is brick and is using the Alpine latest, and the command what is going on here, it is just in the logs, it's printing the secret W1 and secret W2, and the parameter together with secret W3 is saved inside this file, TMP artifact. Okay, so how to know the path of this one? The path, it can be anything in TMP file, in TMP directory. Is best to use TMP because then you are sure that you have the right permission to this file. And so this one container is not using the parameter, but is producing the some output. So instead of as here we had the arguments, so here we have the results. So the result is from this file TMP param, and the target is value. And here we have the TMP artifact, and the target is artifact value. So in this way we can produce a file. So we have some results from the implementation, and this result needs to create the artifact which can be consumed by next one component. So we have the output, and the output is artifact value. So if we go to component 2, then we have and here, if we will take a look, we have this one component and this one component, and we have some edge in our graph that this one output is connected to this one input. So the edges are done by this data structure which is called edge. So of course there is a specification you can which you can check here. So we have the edge specification, and it is described here how to create this one. But we have the source, and the source is node first one node, and the port value we are passing to node N3, and the port is parameter value. So it is just simple keeping the names which are connected here. Yeah. The same with the second one edge. We are passing from this one node to this one node, but the artifact. So if we would change the node with the content from this one file, and here is the second one node. It is also doing some stuff. If we will put everything to component 2, then we will have the component here. As I mentioned, this can be referenced by the reference, by the version reference, and or we can put the component value here. Yes, so going back to our example, so we have some outputs from this one brick, and we have this component which have also some output. So this one component output is the value and the artifact value. So what we can do for this one component, we can create not only the input mapping, but we also can create the here are the input mappings, which we already know what it is. We have the output mappings. So we know that the source in this case is node N3. So N3 is the second one node, and from port parameter value, we are passing. We are mapping this one output port to our output, and the output name is value. So this is the output. So we have the way how we can map the input and the output mapping. Yes, so in such case, in such way, we can create this one component, and in very similar way, we can create this one component. And at the end, we can put everything together as the one huge component, and we can create a workflow. So the workflow is, as was mentioned, is the description of is the recipe itself. So how to do the stuff, and basically this creation of the workflow is really simple because we have the inputs to our workflow. We can also have outputs. Or maybe not exactly outputs for the workflow, because when we have for example, a file output, it should to be saved somewhere. So so basically the workflow we are defining more the inputs here. So we have those inputs seed_t. This is one input. We have the secret L1, L2, and secret L3. Then we have our implementation. So the implementation is a graph, which is this graph is using all of 3 nodes. This one node N1, the next one node N2, and this one is node N4. This is the naming which I used it. So all of those nodes are defined inside those JSON files. Of course, if we will use the real system, everything would be kept inside the database. And in the same way, we are defining the edges inside this graph component. So if we would like connect this one artifact value to this value from artifact, if we would like to connect those 2 ports, we need to create a edge. So this is a value and value from parameter. And what is quite important here, so this one component has some edge which is connected to this one component. So those components will be executed one after the second one. It cannot be executed in parallel, because this one component is producing something, and this one component is using those outputs from the previous component. But this one component and this one component can be executed in parallel, and all of this is done using the Argo workflow. So this is the reason why we use the Argo, because all of those logic is implemented. Yes, in this way we can define our components. And I know that at this stage, creating of those components doesn't look very simple. this is not how the user is creating the component. The components are created in a graphic way using the front end, and the logic there is implemented. So when you will create one output to second one input, then the edge will be created. This is just important for the developers to know how it works. Yes, and at the end, to be honest, what we will get is example job example. So we have a JSON file which is describing the input values, and the input values are here. So the CTT for the job value is 10. So this is described here. Then we have secret L1 is this one secret is taken from the Kubernetes secret. So there is a separate mechanism how to add the secrets to your namespace. So the namespace can be understood as the project. So if you have a project, then the namespace is created for your project, and the secret can be only accessed from inside this namespace. And the same with the secrets L2 and secrets L3. So to be able to run this job, what we need is to have those secrets defined in our Argo system: secret value, secret ID, and the secret path. So this can be done using the front end. We can add those secrets, or it can be done using some magic command. So if I will go to my helper file, so I have some example how to create using the kubectl, how to create the secrets. Then I can go to my command line and I can create those secrets. So so the secrets are created. So I created a demo client secret, demo client ID, and the demo tenant ID. So I created 3 different secrets. Okay, maybe the names are a bit different than here, but I think that in example, if we will go to example, so this is a job example. So we have a secret path. So why my names are different? Whatever, we will check if it works when we will run this this job. So there are, allow me to check if I remember everything what I wanted to say. So we have the specs available, the document stored in database is the component collection, the workflow collection, the jobs, and then we have a component which can be graph, conditional, map. Okay, so the map component is a component for running parallel task. So there is one of a type is a array of, for example, when you are passing a parameter value, you can pass an array of those parameters values, and then for each element of this array, a parallel task will be executed. So inside our map, what it's map component, we have a node, and we have some input and output mapping. So if we will pass the array to this map component, then for each one element of the array, the parallel task with the node defined here will be executed. Okay, so I mentioned that the component can be passed by the value or reference. Then we have a workflow, and we have a job document. And okay, so this final final document, which you can find in the example. So this is a job example JSON file. This one document can be transpiled to Argo workflow, which is defined as the YAM file. Okay. And one more important thing, the transpilation process can be done on the dereferenced documents. So if we will, for example, replace this node with some UID here, so before the transpilation can be done, this needs to be dereferenced. But of course, in the code there is a mechanism how to do it. So we have transpiler, and we should to have also dereferencing stuff. So if we will go to commands, and we have dereferencing stuff, and the dereferencing stuff is using the model storage and the method. Okay, to be honest, I don't know. I don't remember where the dereferencing method is right now, because I haven't been working on this project for more than 4 months. But yeah, the document can be quite easily dereferenced. So if we will if we will take a look at this one example, we have some useful tools added to the software. If we will go to CMD, we can take a look what kind of tools we have. We have a tool to dereference. So if we will keep the referenced JSON with some database, then we can dereference this using this tool. And we have a transpile tool, and we have a validate tool. So first of all, what we can do, we can go to validate, and we can check if our created document validates correctly. So we can do go run mine.go, and then we need to define a schema, and all schemas are defined in models. What we have here, model spec. And we know that we would like to validate the job. So we need to use job schema.json, and now we can pass the file which we would like to validate. So it's a JSON file. It will be in models example job example.json. So yeah, we can see that the schema validates, so everything works correct. And for example, if we would like to, in this jobs example, if we will remove, I don't know, if we would remove one of the required elements from this file, then it won't validate, and you know that you should to look for some errors in your document. And then we also can go back and go to transpile process. And the transpile process, I will try to say a few words later, but first I will show you the example of transpilation. So if we will go to transpile, and we will do go run mine schema, where we would like to run job, and then the file job example, models examples job example dot. Yeah, so as the output, we will get Argo workflow in the YAM file. So it contains some stuff like API version, the kind of the document. This kind is workflow. Then we have some metadata. Then we have some specs with the arguments input, which is the entry point, and then our important structure of the workflow starts. So when we are doing a transpilation, each one component is translated to a DAG object from the Argo. So the DAG object contains some tasks, and the tasks are nested nested tasks which should be executed, and each one task is referenced by the template. So if we have this one task, then we should to have such a template in our document. So if we will go later, we can see that we have a container here, which the name is exactly the same one. So this template is showing this name of this container. So as I said, each one component is added to the Argo workflow as the DAG. However, the brick component is added as the container, because a container is something what is executing our work. So what we can do, we can go back to this translation job. Translation job, and then we can save this to some job YAML job.yaml file. So right now we have this tmp job YAML file, and everything is put it here. Of course, we can use our endpoint to do all of those stuff, but it's quite useful to know how to do it by yourself. And then what we can do Argo, and the namespace in this case is sandbox project A. We can take a watch what will happen, and we can take a logs, and we can submit this translated document. So tmp job YAML. Okay, so because of this watch parameter, we have some information here, and right now the job name is workflow example, and the namespace is defined here. Here we have some additional information, and what you can see here is the output from the Argo server. So our first brick, if we will take a look at our first brick, so it was brick 1. What this one was doing is was printing the output from the seed N1 parameter, and it was printing the secret B1 and secret B2 values. And so if we go back here, you can see in the logs that this is the value which was passed as the parameter, and we have the value of secret password and the value of secret ID. So this one just show us what is going on, and it was executed. This one container, and later is the output for the remaining containers. And this example is not doing any very clever stuff, but is mostly printing the value which are passed or some the content of the artifact which is presented. And as we can see here, everything goes well because we have this workflow example, and the node N1 was executed. Node 2 was executed, and inside node 2 we executed those two nodes, and the last one was node 4 executed after this one. So this is how it works. And the transpilation process, some most important information is here that this is to transpile from Flowify to Argo. We are using a recursive function. So when we are passing the documents with this defined job, a function is going to each one node, and when we the function is starting from the job, so from the most outer circle, and when it's going to the next one circle, so we have those input mapping and so on. So this function which is defined here in transpiler this is the basic function which starts here, get Argo workflow, and we are creating some maps because those maps are required for us. Those are maps which are created in memory, which are telling us what are the names of the secrets in each level of the graph. And is the same for the volume maps, is creating in the same way. And then we have a function parse component tree. So when we create this secret maps and the value map, we are going to this function parse component tree. And this parse component tree is recurrent function. No, sorry, this one is the recurrent function, traverse component. So here in parse component tree, we are taking a workflow, not the job, but the workflow. And the most outer component from this workflow is taken and passed to this traverse component function. And the traverse component function is taking the component. So when we are going inside this function, we are doing some stuff to check the inputs, to save the inputs in the maps, and then we have some output and so on. So this is less important. But then we are trying to we are checking what is the implementation of this component. So we are taking the type of the implementation, and if the type is conditional, then we have a function add conditional node, and this one is adding the conditional node to our Argo workflow. If the type here is map, then we are adding the map component to our Argo workflow. And then later we have the same add graph method, and all of those methods are defined here. It's really pointless to explain what exactly those methods are doing here, because everyone need to go through this quite carefully to understand what is going on. But this is the most important part, that we are traversing component. And for example, when we are going into a graph component, we have this method add graph. So this one is adding some stuff to Argo workflow. But later, as you can see here, we are for each sub nodes of the graph, we are executing this traverse component function one more time. So this is a recursion which is executed. And the last one is, of course, when the implementation is brick, then we have the add brick, and the brick is some kind of leaf in our tree. So there is no more traverse component method inside when the type is brick. Yeah, so basically this is how the transpilation process works. So this is a recursive function with the job document input, and then we have during when we are traversing this tree, we need to create the map to remember that this one secret L1 on this level the name is secret G1, and when we are adding this brick, we know that the name is secret W. To be able to show that the name of the secret W inside our system is secret L1, then we just need to create those maps when we are traversing the document, and we need to pass this map into the each next one component. Yes. So not this one. This one. This one I already mentioned that each Flowify component is added as the Argo DAG with the some tasks, and the brick is added. Okay, so here Argo task template can be nested DAG or a container. So if we have a Flowify brick, then this is a Argo task template. Okay, I know that this is a lot of information. I hope so that the recording will be helpful. There was just one question during the meeting, but we have still a few minutes. So if you have any other questions, then don't hesitate to ask.